Okay, so we want to solve this problem. The number of bacteria in a sample is increasing according to an exponential model. After 2 hours, the sample contained 200 bacteria. After 6 hours, the sample contained 800 bacteria. All right, so this follows a basic exponential growth or decay model, which looks like this: y equals to a times b raised to the t. And I have all these items labeled for you so you get a general sense of how to do it. All right, and then I'm going to use a modified version of that, which is really the same thing. I just changed the letters so it's just a little bit more understandable relative to our problem. So P stands for population, P0 stands for initial population, B is still the growth factor, just like up here, and T is the time, just like up here. All right, so our facts: we have after 2 hours, you have 200 bacteria. After 6 hours, you have 800 bacteria. So let's first write equations to represent both of those two sets of facts. All right, so we have 200 bacteria. Initial population, I don't know. Growth factor, I don't know. And we know 2 hours has gone by. So I'm just following this equation down here, okay? Putting in the two numbers into that equation. So the second set of facts, 800 bacteria. Again, initial population, we don't know. The growth factor, we don't know. And the time is now 6 hours. Okay, so now we have a system of two equations that need to be solved simultaneously. All right, this is very similar to Algebra 1 when you solve systems of linear equations. However, this is a little different. Okay, so one way we can solve it is by dividing the top equation by the bottom equation, meaning 200 divided by 800 is equal to P0 times B squared divided by P0 times B to the 6th power. 200 divided by 800 reduces down to 1/4. Okay, if you divide the top and bottom here, the P0s will cancel out. And now I have a B squared divided by B to the 6th. And you know that your exponents will subtract 2 minus 6. All right, and the result of that is 1/4 equals to B to the -4 power. Another way of writing that is 1/4 equals to 1 over B to the 4th power, because you know negative exponent means reciprocal. If I flip both fractions, I get 4 equals to B to the 4th. That's true. And then I want to take the 4th root of both sides of my equation, the 4th root, because the 4th root will clear out the exponent of 4. So now I have B all by itself, and I have the 4th root of the 4th root of 4. How do you deal with this? Well, we can simplify this a little bit, because I can rewrite this as 4 raised to the 1/4 exponent, right? If you remember your rules for fractional exponents. And then I can rewrite the 4 as 2 to the 2nd power. So this is 2 to the 2nd power raised to the 1/4 exponent. And 2 to the 2nd power raised to the 1/4 exponent, you know the rule says your exponents will multiply. So that's a 2 times a 1/4, which is 1/2 when you reduce that. So this is really 2 to the 1/2 power, or B is equal to the square root of 2, because that is what the 1/2 exponent means. So we found one of the pieces of my puzzle. The growth factor is the square root of 2. Got it. What do we do with it? Well, we can use either equation number 1 or equation number 2 to backtrack and find the initial population. I'm going to use equation number 1. 200 is equal to P0 times B squared. I know B to be the square root of 2, so this is 200 is equal to P0 times the square root of 2 squared. The square root of 2 squared is 2, so this is 200 is equal to P0 multiplied by 2, and I can get rid of the 2 by dividing it, and I get 100 is equal to P0. So I now know the second piece of the puzzle to my problem. All right, I know the initial population and I know the growth factor, and we are looking for the equation that models this, right? That's what we're looking for, the exponential model, where here's my model. And the only thing I'm going to do is take out the two variables that I don't know and put in the two facts that I just found out. All right, so P is a variable. Initial population P0, we know that's 100. Times the growth factor, the square root of 2, we know that. And that growth factor is raised to the exponent T for time, which is a variable. All right, that is my equation that models this problem. And there you go. That's your solution. Take care.